this one first, and okay, right. So you guys can see the screen. Yes. Thank you very much. So for today, we sit with hydrogen manufacturer. Okay. But before we proceed with partial oxidation process, perhaps we can recap a bit what we have learned last Thursday. Okay. So last Thursday, we have gone through CO2 production and purification process. CO2 can be produced by different processes, such as synthesis of ammonia. It is also can be found in as a byproduct in the production of substitute natural gases. You can also find it from fermentation, which we have gone through details last Tuesday. And then from the oil well also. The first one, basically on the fermentation process. This is considered as the major process in the production of CO2 in industry, okay? Because people produce beverages like beer, wine, and whatsoever. So at the same time, they actually can produce CO2 as a byproduct. So this process occurs concurrently, right? And if you notice over there, okay, the raw material used for fermentation is basically biomass or any types of resources that contain sugar. Because you know, yeast will be the main microorganism that will consume hydrocarbons, which in this case, sugar or biomass, and then convert it into alcohol and CO2, right? This is also the biochemistry process in production of ethanol. You can see from glucose, it will undergo glycolysis. So this, a well-famous process of glycolysis is known as Krebs cycle to produce pyruvate. And then from the pyruvate, it can produce acetaldehyde, and from acetaldehyde, it will cleavage and I think produce CO2 plus with ethanol. And talking about CO2 from fermentation, it is important that from fermentation process, you have to understand that the gas produced is basically not pure because it still have a trace of alcohol a bit. I mean, other than that, you also have a trace of moisture, acid, and whatsoever. So that is why it needs to undergo purification step. So this is actually the importance of purification. So to ensure that the end product or the produced gas that is produced as the product will be highly pure and didn't contain anything. Okay? So over here you can see that it contains like 6 to 7 scrubbers, which the 3 scrubbers initially is actually on alcohol scrubbers and water scrubber, 2 water scrubber. So the function of alcohol scrubber is basically to remove the trace of alcohol, and then next it goes to the water scrubber with a function to remove water soluble impurities before it goes to the gasometer, which function as an electrolysis cell and separates the gas or any unwanted materials like water. When it electrolyzes, it will become like oxygen and hydrogen, and the CO2 will further goes into a bichromate scrubber, or sometimes known as dichromate scrubbers, which the function is basically to oxidize the alcohol and aldehyde that contains in the CO2 mixtures. And next, it will goes into a cooler. Okay, it will be chilled and then goes into a acid scrubber or sulfuric acid scrubber. So sulfuric acid scrubber function as dehydrating agent, right? Which further after that goes into the sodium carbonate scrubber with a function to remove the entrained acid in the gas. And when the gas has been neutralized, then the CO2 will be released. And finally, the CO2 will goes into the oil scrubber to remove or to absorb the oxidized product and send the odorless gas into the compressor. So that is why I mean CO2 produced later on doesn't have any acid or rancid smell. It will be like odorless and whatsoever, right? So next we have gone through also on hydrogen gas. Okay, so hydrogen gas, known as a renewable fuel for the future, can be produced from electrolysis of water, from microbial electrolytic cell, steam gasification, and this is actually the methods that we've been discussing previously. It is basically on steam reforming process, right? So the steam reforming process actually tells you that the hydrocarbon will be used as a source, which in this case, the types of hydrocarbon used will be the light hydrocarbon, like methane, ethane, propane. This is actually the examples of light hydrocarbons, which normally used for steam hydrocarbon reforming process. The idea is basically it will go into the reforming process first, okay, before water shifting process. So reforming process is basically based on the reaction between light hydrocarbon with steam or water to produce carbon monoxide plus with hydrogen gas. And this carbon monoxide will be further goes into the two scrubbers at the higher temperature and also at the lower temperature. This step is known as water shifting process, which convert the CO2 into the carbon monoxide into CO2 plus with hydrogen gas, right? So this equation and also the condition need to be remembered. I believe it is not something difficult for you guys to memorize the flow diagram, okay? So you can actually memorize this, and then the two process which important to be defined, which on reforming, okay, the reaction and the condition at the higher temperature and the lower pressure. Okay, so excess steam will be used. So again, the function of excess steam is basically to convert most of the hydrocarbons into carbon monoxide. Okay. The next process, known as water gas shift reaction, as I mentioned earlier, that the carbon monoxide will be reacted with steam to produce carbon dioxide plus with hydrogen gas. This process actually occurs at the mild endothermic process at the lower temperature. And things that you need to remember is the catalyst used in this process is basically iron oxide. So the rest is actually on the characteristic of this process. It produces quite high percentage of hydrogen gas, around 75%, right? And as I mentioned earlier, that if you want to increase the percentage of the hydrogen gas, you can actually install a few water gas shift process. Okay, this actually will ensure that most of this carbon monoxide will be converted into CO2 plus with hydrogen gas. So today actually we are going to discuss on the other methods, the second methods of hydrogen manufacturing, known as partial oxidation process. I've mentioned to you briefly on Thursday that partial oxidation process basically deals with a moderate hydrocarbon number. For example, like butane, pentane, hexane, and whatnot. Okay. The function is to ensure that this moderate or slightly high molecular weights of hydrocarbon can be utilized for the production of hydrogen gas. If you notice over here, the natural gas will be pumped into the partial oxidation unit together with oxygen gas and steam. If you compare between steam reforming process, the steam reforming process just react the hydrocarbons with steam. Meanwhile, for this process, the name itself, oxidation, it means that it requires oxygen, the use of oxygen. That is why you will notice over there that one of the main ingredient for this process is basically oxygen and also steam, right? So it goes into the oxidation unit, and after that it goes into the chiller, condenser, okay, and finally the gas produced, because it's still a mixture of hydrogen gas with carbon monoxide, okay, and carbon dioxide. It will be refined using a adsorber. So the type of adsorber used normally is PSA, pressure swing adsorber. Okay, so the types or the material used for the adsorber is normally like zeolite, activated carbon, and whatsoever. Okay, you notice over there, they also use a type of chemical, monodiethylamine. So this also function, okay, for the purification process. Right. So the next rank, okay, to steam hydrocarbon process in the amount of hydrogen gas made. Okay. Use natural gas, refinery gas, or other hydrocarbon gas mixture as a feedstock. Right. So the benefit also accept liquid hydrocarbon feedstock such as gas oil, diesel oil, and heavy oil. Right. So this actually part of the advantages of using partial oxidation process, which thing for the other methods, the steam reforming process, you cannot use liquid hydrocarbon. Mostly the types of hydrocarbon used is very light and mostly in gas properties. Partial oxidation is also known because of its non-catalytic partial combustion of the hydrocarbon feed with oxygen in the presence of steam. So the idea, as I mentioned to you, is that hydrocarbon will be reacted with oxygen, will be combust, it will be burned, and then after that, the CO2 produced will be reacted with water. Okay, so this actually produce carbon monoxide and also hydrogen gas. Okay, so the combustion chamber temperature is around 1300 and 1500 degrees C. Okay. So the example used is actually methane. Methane is very simple in structure, but it's just an example. The first reaction is highly exothermic and produce enough heat to sustain the other two reactions. Okay. For efficient operation, the heat recovery using waste heat boilers is important, and the product on the gas composition depends upon the carbon to hydrogen ratio in the feed and the amount of steam added. So normally the steam added must be also in excess. Okay. A pressure doesn't have a significant effect and conducted around 2 to 4 megapascal. So 2 to 4 megapascal is still considered at the lower pressure. This permits the use of more compact equipment and reducing compression costs. Okay. So since like low pressure was used or is used during the process, so you wouldn't require to install any compressor. Right. So the composition of mixture from partial oxidation process, you will see that the amount of hydrogen gas is not as high as steam reforming process. So for steam reforming process, again, what will be the percentage of yield that you will get? Anyone knows? Anyone can answer? Someone?
75.
75. Good. Okay. So 75, and when you compare with the partial oxidation process, it's around 48. Do you think that is there a way how you can increase the percent of hydrogen gas for partial oxidation process? Anyone knows? Any suggestion? What do you think? I mean, chemists or engineers always have to think about like how to increase the yield of a product. So what would be your idea? Anyone? I mean, maybe I should call names. No Nadiha. No Nadiha. Are you around? No Nadiha? Ada tak ada? No Nadiha? No. Tengah makan. Outside. Quiz Bay maybe. Okay. Nurul Amilin. Amilin, are you around? Okay. So, Amilin, what would be your suggestion to increase the percentage of hydrogen from partial oxidation process? What would be the idea, or what would be the strategies that you think would be efficient?
I'm not so sure, Doctor.
Anyone wanted to try? Nurul Nafiza. Nurul Nafiza. Nurul Nafiza ada? Nafiza pun tak ada. Ada kat Queens Bay juga. Okay. Pui Lingko. Pui Lingko. Are you around? Yes, no? Same. Still like Queens Bay. Okay. Right. One wicket. Wicket, are you around?
Yes, Doctor.
Oh, very good. Okay. So Wicket, what do you think? If you want to increase the percentage of hydrogen from partial oxidation process, what will be the idea? What will be the strategy? You think that it is possible?
I'm not sure. I don't know.
Okay, all right. But actually the answer is written over there at the same slide that you see just now. Okay. You know that for partial oxidation process, it still produce carbon monoxide and also carbon dioxide. Okay, so carbon dioxide has a quite high amount, like around 46%. So the idea is perhaps after partial oxidation, okay, you can actually install water gas shift conversion, which means the one that you saw in the previous method, okay, in steam reforming process, you can adopt just one part of it and later put the last part after partial oxidation. Okay, because you can see over there the CO percentage is quite high, like 46. If you can convert this 46 into CO2 plus with hydrogen gas, then this actually can increase the percentage of hydrogen. Okay, perhaps maybe more than 50%. Okay, any question so far? Anything? Anything want to ask?
No, Doctor.
Moving on to the next process. The next process is just for your information. You can also produce hydrogen gas from coal gasification process. Okay, so gasification process is basically the burning process of a material, normally biomass or a feedstock. Okay, that actually incorporate together with coal, okay, charcoal and whatsoever. Okay, because charcoal or coal will be function as the carbon source. Okay, and when you burn it, okay, you know that most of the biomass will be converted into gas. So that is why it calls as gasification process. So after gasification, it goes into the absorber or refinery column that will separate the different gas. Okay, so gas produced will require the water gas shift conversion and subsequent purification to produce high purity of hydrogen gas. It's the same thing. I mean, like after you do gasification, you can also install water gas shift process in order to have a higher percent yield of hydrogen with the same time and increase in purity. Wow, I think it's not quite visible here, but perhaps maybe later on you can look into the details. This is actually the comparison between steam reforming process, electrolysis, and cold gasification. Okay, right. So most probably it depends on the source that you have. Whether you have hydrocarbons, lower weight of hydrocarbons, then you will choose steam reforming process. If you have slightly moderate hydrocarbon mass, then you can use partial oxidation. If you don't have, a hydrocarbon source, but instead you have water source, you can use electrolysis. Okay. If you have a biomass as a source and coal, then you can actually use coal gasification process. So all actually have its own unique features. So uh, perhaps later on you will see what will be the advantages and disadvantages, right? Oh, okay. So the other homework that I believe you guys can do is probably you can do it towards the end of this week. It is actually on the purification process of hydrogen. Okay, how actually you can purify the mixture of hydrogen gas, probably because of it also produce carbon monoxide, carbon dioxide, and H2S. It is actually in the case of if you use fossil fuel as a source, then you will have hydrogen sulfide gas as well. So the hints over here that you can observe is basically look into the use of mono or diethanolamine chemicals. Okay, so this one of the methods used to purify hydrogen gas. Another method that you can use also is by hot potassium carbonate reaction. Okay. Other than that, you can also look into a process of adsorption purification using thermal and pressure swing adsorption. I have mentioned pressure swing interaction in the previous slides, which actually use zeolite as the main materials. And because of zeolite is very porous, it can actually use as an absorber or separator of gas. Discuss the advantages and the disadvantages of this process. So you can look into these three processes and then discuss the advantages and disadvantages. I put also some link, YouTube link uh, to get some idea, okay, how you can do the purification of hydrogen gas, right? At the moment, okay, I still have not divided you into groups. I guess perhaps later on, I will divide you into at least 5 groups, okay? And you can actually, the next homework that you can do is you can do a presentation, like a PowerPoint slides or videos or whatever. Then we will consider that as part of your assessment for presentation, okay? But meanwhile, for this one, I guess you can do it as your homework. I will later on create an event. Okay. I saw the assignment, the homework that I gave to you last week, but I believe not everyone is actually submitting the homework. So I don't know, maybe you are not aware or what, but the homework is actually very easy, is to discuss the difference between batch reactor and also continuous stirring tank reactor, and at the same time to draw the flow diagrams of an experiment process. So some who have done it, congratulations. I will evaluate you guys after that. But those who have not submitted, I guess maybe please do this. This homework, because I set it with a deadline. So if you submit it later, you cannot submit it, right? So remember, your assessment is essential for your grading. Right. So we are moving on to the next type of gas. So we have gone through CO2 and H2, and now we are looking into the gas used all over the industries, even in the healthcare lines. You will see that people are using oxygen gas for treatment and so on, right? Okay. But before we move on to oxygen gas, this is just something that I want to share with you guys. The current research, it's not really current, but I believe a few years back, people have discovered that if you inhale hydrogen gas, it can actually, use as a good treatment for cancer. I mean, people who inhale oxygen gas, it is reported that yes, the cancer cell, the cysts and everything are shrinking. In fact, people who suffer high blood pressure and so ever, when they actually inhale oxygen gas for a certain period of time, it actually improves their health. Okay, so this is something that you might think it is interesting. And I guess for your information, in our school, we have one lecturer who is currently working on, I think, hydrogen storage, which is Dr. Chua. So if you are interested on this research, you can always contact Dr. Chua. Right. So moving on to the next type of gas, oxygen. Oxygen was discovered independently by Carl Wilhelm Skleen in 1773 near Uppsala. Okay, Uppsala. I hope anyone knows where is Uppsala. So it's at the Scandinavian country. The term oxygen was first coined by Antoine Lavoisier in 1777. Okay, it is used in cellular respiration and major classes of organic molecules in living organisms. Human beings using oxygen for respiration, other animals, other types of animals, even other materials is also using oxygen for various types. Okay, so it is continuously replenished by photosynthesis. Photosynthesis actually is a process where the plant consume CO2 and then convert it into oxygen. So, which means the oxygen source is always all the while from photosynthesis process. Okay, oxygen can be considered too chemically reactive. Imagine your high school experiment. If you have oxygen gas, you put a wooden splinter, what happened? It will glow. Okay, this wooden splinter, and you will see fire. Okay, commonly used in residential heating, internal combustion, production of steel and plastic. I think in the next few chapters, chapter 4, you will learn about extractive metallurgy, and you will learn how you can produce steel. And the process is basically use a lot of oxygen, smelting process and others. Okay. Life support system, aircraft, submarine, and also diving. The manufacturing of oxygen gas. Okay. The manufacturing of oxygen gas can be various. It can be produced via, of course, air separation, because the atmospheric air contains certain amount of oxygen. Okay, and from the separation using an adsorber, you can actually separate oxygen. A few methods like cryogenic process. Remember, if there's any words that says cryo, so you know that this always related with cooling process. Cryogenic, you cool, or you use a cooler. Okay, the reason is because the cryogenic process, you actually compress the gas first. Okay, so when you compress, you cool it down, so the entropy of this gas will be reduced. And what happened is the gas, the atmospheric air, which have been compressed, will become liquid. So it will actually pass through absorber or refining column that will eventually separate, different types of gas. You can also use pressure swing adsorption, PSA, again, okay, using adsorber like zeolite. Okay. You can also produce oxygen gas from electrolysis of water, the same thing as the production of hydrogen gas. And you can also produce oxygen by chemical reaction, which oxygen is free from chemical compound. Right. So this is basically the process flow sheets of oxygen and nitrogen production. And this process is basically use atmospheric air as the source. You can see over here that the atmospheric air will be used and then it goes into the compressor. So compressor will function to compress the gas. Okay, so when you reduce the volume of the gas, because you compress it, so what happened is you'll see that gas initially it's following the Brownian motion, Brownian motion, and when you actually compress it, it will become the volume will become smaller, and then the molecules will be almost like close to each other. So when it goes into the cooler, so as I said, when you put into a cooler, what happened is it will change the characteristic of this gas by means of the entropy. So what happened is it will become a liquid gas. So the liquid gas, okay, will goes into the water separator just to maybe to remove the trace of water that contains in your liquid gas, because remember the water that might present in your atmospheric air is actually coming from moisture or vapor. Okay, and then after that it goes into molecular sieve. So the types of sieve used normally zeolite. This where PSA pressure swing adsorption process is applied. Okay, so it separates the gas and then goes into the compressor. Again, will compress and cool before it will be expand. So you'll see that over here it will separate nitrogen, and then over here it will separate oxygen. So oxygen goes into this high pressure fractionation column and goes into the low pressure fractionation column. And finally, you can get oxygen and the nitrogen also. Okay, right. So you can actually read the details from the process one until the next. The air is compressed. So first, it is compressed about 94 psi in the multi-stage compressor, and then it will pass through into a water cooler to condense any water vapor, and condensed water is removed from the water separator. The air passes through the molecular sieve adsorber. As I said, the adsorber actually contains zeolite and silica gel type adsorbent, which trap the carbon dioxide, the heavier hydrocarbon, and any remaining trace of water vapor. So periodically, this adsorber need to be cleaned or need to be removed. Okay, so to maintain the purity. So this usually requires the two adsorber operating in parallel, so that if you have like one adsorber failure, you have another backup, just to like two times assurance. Okay. The pre-treated air will be split, and the air portion of the air, the air is diverted through a compressor, which pressure is boosted. Then it is cooled, which then allowed to expand to the nearly atmospheric pressure. This expansion rapidly cools the air, which is injected into the cryogenic section to provide the required cool temperature of the operation. And the main stream of the air passes through one side of a pair of plate fin heat exchanger operating in series, while a very cool oxygen and nitrogen from cryogenic section passes through the other side. The incoming air stream is cool, okay, while the oxygen and nitrogen will be warm. In some operation, the air may be cooled by passing it through an expansion valve instead of the second heat exchanger. So in either case, the temperature of the air is lowered to the point where oxygen has the highest boiling point. Okay. So the airstream now, as a part of liquid and part of gas, enters into the base of a high pressure fractionation column. Okay, right? So as the air works its way up to the column, it loses additional heat. Okay, the oxygen continues to liquefy and forming the oxygen-rich mixture in the bottom of the column, while most of the nitrogen and argon flow to the top of the reactor as a vapor. The liquid oxygen with mixture, which normally calls as a crude liquid oxygen, is drawn into the bottom and the lower fractionation column and further cooled in the subcooler. Okay. Part of this steam is allowed to expand to nearly atmospheric pressure and is fed into the low pressure fractionation column. Right. So at this time, you will see that it will give high purity of oxygen around 99.5. Yeah? Meanwhile, the nitrogen and argon vapor from the top of the high pressure column is cooled further into the subcooler. Okay, and this also will give the purity as much as 99.995% of nitrogen. The argon, okay, which has the boiling point between the oxygen and nitrogen, remains a vapor and begins to sink in the nitrogen boils off. The argon vapors reaches a point about two-thirds the way down of the column, and the argon concentration reaches its maximum about 7 to 12% and is drawn off to the third fractionation column, where it is further recyclated, okay, and refined. So this actually will produce around 93 to 96% of argon, okay, which actually have a lower percent of oxygen. It is actually the byproduct. I mean, because the earlier process you already separates the oxygen at the first column around 99.5. Okay. So hybridity of oxygen, if the higher purity is needed, so one or more additional fractional column may be added in conjunction with lower pressure column, okay, to further refine the oxygen product. So in some cases, the oxygen may also pass over a catalyst to oxidize any hydrocarbons. This process produce carbon dioxide and water vapor, which are then captured and removed. If the oxygen is to be liquefied, okay, this process is usually done within the low pressure fractionation column of the air separation plant. The nitrogen from the top of the lower pressure column is compressed and cooled and expand to liquefy the nitrogen. This liquid nitrogen steam is then fed back into the low pressure column to provide the additional cooling required to liquefy the oxygen as it sinks to the bottom of the column. So this is actually how the purification of oxygen been done. As I said in the previous slide, you will see that if you need more purity of oxygen, then you will install or you will add more fractionation column, okay, with low pressure column features. So over here you will see that the pressure swing gas, the pressure swing absorption unit installed is around 3, but the more columns that you have, the better the purity of oxygen that you will get. Okay, so this is actually the first process, and when it enter to the absorber, you see that it will produce the oxygen gas with a highly purity. But remember, in some company they just install only 2 or 3, the most 3, because the cost of installing this PSA is actually not that cheap, okay? And the material itself, like zeolites and others, is actually kind of expensive to be used. So that is why I think the most they in industry they just install like 2 to 3 column tank only, right? So the use of oxygen, you can see as I said, as a life support for animals and human. Oxygen and acetylene are combusted together to provide a very high temperature, which needed for welding and metal cutting. So when oxygen is cool, like around minus 183, it becomes a pale blue liquid that is used for rocket fuel. So those who might wonder, liquid oxygen actually has a color like around pale blue color, and this actually used as one of the main fuel for rocket. It is used in the blast furnace to make steel, and it is important component in the production of many synthetic chemicals, including ammonia, alcohol, and various plastics. So I think for liquefaction, we will continue tomorrow. But before that, allow me to maybe share the videos with you guys, perhaps maybe just to give you some idea. Right, where is it? I think I will share a few videos related on the purification of hydrogen as well as the oxygen gas. Maybe just video, the oxygen plant. Oh, all right. Let me share. Okay, so I hope you guys can see the slides. Not really the slide, the video. Doesn't have any sound, I guess. Okay, so this is actually how PSA works. So you will see that the gas goes into the compressor, and it has some like, to filter off um, this the gas. If it has some purity, okay, compressor, dryer. Okay, so it compress first to reduce the size, dryer to remove moisture, tower to absorb oil particles. It goes into the air, okay, the PSA. So this one actually the pressure swing absorber, okay. So it is actually equipped with mostly zeolite particles, very porous materials. Okay, so you see that there's a two column used in PSA, right? And then, this is actually the feature is zeolite filling with its ion exchange and trap nitrogen and oxygen. Okay, right. So after that, it will goes into the product tank. Okay, it will enrich the gas produced, and finally, uh, finally you can see it will be stored. Okay, let's stop this one. Right. The other videos on oxygen plant.
Welcome to Universal Oxygen, the world leader in air separation plants. present this groundbreaking and unique product, which is going to change the trends of the current industry.
Right, so this is the air compressor. Basically, the source will be the atmospheric air, and as I said, if you refer to your slides, the first step it will goes into the compressor. Okay, so the air pressure will be compressed. This is actually the working condition. Right, and then after that it will be cooled. Okay, so the air will be cooled to liquefy the compressed gas. So this is actually the air pre-cooling unit. So it has a chiller. You'll see here is actually the chiller used for cooling. So this actually the setting parameters. This of course a pressure gauge, just showing you the working condition. Normally at the lower pressure. Okay. You have a few pressure gauge. The function is because you have like initial feed of your gas, maybe at the lower pressure, and then after that, yeah, slightly increase. So this is a air buffer tank. So this will create the air cushion for the first stage of oxygen purification. Right. So this the first stage of oxygen purification system using PSA. Still is a PSA. You see the zeolite column is actually these two. And this is actually the working condition. You have yeah, the gas has been entered. So the initial pressure is around not much, maybe almost 0.45. Okay. Goes into the second column, and then after that the final column still maintained at the same pressure. Right, so this is actually connected with a controller. So the controller actually controls the valve, okay, to ensure that when it goes into the column, it goes not directly but in stages. First you charge the gas, and then after that it goes to the column, and slowly pressure is applied to ensure that it goes into the absorber, and the absorption process will occur smoothly, so without damaging the column. So it says that the process is repeated for every few seconds. Right. So this is a waste nitrogen venting flow meter. So just to show you, the nitrogen has been separated. Okay. This is the second stage of oxygen purification, still using PSA. But this time you will notice that the column is slightly bigger. The second stage is known as a booster because it purifies, okay, the air from the first stage, okay, and this actually to ensure that you have a more pure oxygen gas after that. Okay, so it has a like absorption tower, muffler, solenoid valve, okay, pressure switch, gauge, and etc. All the controls. Same thing, you have a inlet pressure, still zero because it's not been charged yet. So this is actually the current pressure inside the column and outside the column. So now they have like pump in the gas. You will see that the pressure is slightly increased, right? Yeah. Now the absorption process start to occur. Okay, so this